Hi, good morning. I'll be describing technology that we developed for providing software-defined networking on InfiniBand Fabrics. This is really an evolution of technology that was developed at Seego Systems, which was a company that was acquired by Oracle close to 4 years ago. And it was developed for providing a converged fabric on InfiniBand, where beyond the high-performance inter-process communication, you would also get connectivity to other fabrics, Ethernet and fiber channel, as well as virtual networks on top of InfiniBand Fabrics. And this was evolved into being part of a product portfolio that Oracle recently announced. And also this technology is used in an engineered system from Oracle. I'll describe how it's actually applied in a product. So our goals when architecting this solution was to provide, as I mentioned, virtual networks over InfiniBand, software-defined virtual Ethernet networks. So basically provide a large number of networks that could be used for different applications or multi-tenancy, such as in cloud environments, and basically enable communication between applications that are not IP aware and don't use the low-level InfiniBand verbs or ULPs that are specific to InfiniBand, but expect a virtual NIC and an Ethernet NIC, a layer 2 NIC. And also provide communication between InfiniBand connected servers and Ethernet connected servers, that is, have gateway hardware that connects the two potentially to multiple different networks. So you could have different isolated Ethernet networks, all of them with all 4,000 VLANs, all connected into this system and accessible from the servers through virtual Ethernet networks through virtual NICs. Clearly, this needs to be secure and isolated. As I mentioned, it's for multi-tenancy environments, among other things. Fault tolerant, so basically be able to have redundancy, the ability to bond multiple interfaces, and sustain cable failures, switch failures, gateway failures. High performance, which means offloads, typical Ethernet type offloads on the servers, as well as a low latency Ethernet gateway between InfiniBand and Ethernet. Also support all the different types of models of I/O, be it para-virtualized I/O, SRIOV, or bare metal non-virtualized I/O. In addition, we wanted to have network services. So these networks, if you have multiple virtual networks, you might want to do routing between these networks, let's say between an overlay on InfiniBand and a network that has an uplink into an external network, might be on different layer 3 subnets, and you want to do routing between them. Typical things like load balancing, firewall, VPN gateway, all of these need to work in conjunction with these software-defined networks. And obviously the software-defined aspect, which means it's all dynamic, can be created, removed, assigned to servers, monitored with a management tool in a flexible manner. So if you want to connect, for example, a server to some Ethernet network, you don't need to cable anything, you don't need to do anything in any kind of hard-coded manner. It's all dynamic through a management tool. You can connect whenever you want, any server to anything. So how did we solve this, provide a solution for all these requirements? We implemented virtual networks as overlay networks on InfiniBand. The Ethernet packets are encapsulated in IB messages using unreliable datagram. We do have an option also for RC, reliable connection, as an option for the transport. For UD, obviously, if you want to send jumbo Ethernet packets, large ones like 9K, you want to have a large MTU. So we do support the 10 kilobyte InfiniBand MTU for this encapsulation. The broadcast domain of a virtual network is mapped to an InfiniBand multicast group. And the learning and aging happens in the server drivers and in the gateway. So basically it operates based on observing ingress packets and populating a forwarding table in the server drivers, a VNIC, virtual NIC driver, and the Ethernet gateway operates in a similar way. And providing the ability to assign virtual networks to InfiniBand partitions for isolation. For the performance, we provide offloads in the HCA, so things like checksum offload, large send offload, RSS, TSS, all provided in hardware on the HCA. And in addition, we put security enhancements in the HCA specifically for this purpose, including anti-spoofing and also firewall capabilities, layer 2 to layer 4 firewalling in the host channel adapter. So here's an example of a virtual network without an uplink with fault tolerance. So you expose these virtual networks on the server as virtual NICs that act basically like a physical NIC. And you can expose, for example, in this case, 2 that are on the same virtual network and use a standard bonding driver on top of that for the redundancy. As you can see here, the broadcast domain is mapped to an IP multicast group. And you could have a virtual network that has an uplink into physical Ethernet. And here's an example where you have this model with redundancy. So you have the 2 gateways connected to the same Ethernet network, and you have servers that have 2 VNICs each, and each one talks to a different gateway. And you basically have the gateways being capable to broadcast on the relevant multicast groups that are associated with them. So if they need to flood or if they need to send a broadcast packet, they use the multicast group. Obviously, this gateway is specialized hardware that's used for that. I will show you what that is. So the address resolution I mentioned a little bit. You basically maintain a forwarding table that maps the destination MAC and VLAN or that are on the packet to an IB address handle of another server or a gateway. So basically, the VNIC driver learns who owns the MAC VLAN. And so he knows who to forward the packets to. It's based on learning from ingress traffic. So you see packets coming in, you populate this table, there's aging. If you don't know who owns a packet, then you flood it on the broadcast domain, which is the multicast group. And the gateway operates similarly. It basically it doesn't learn on the Ethernet side, it learns on the IB side from the servers. Again, who owns the packets through building the forwarding table from learning from the packets that come in from the IP side. So what you can build basically is virtual networks that can be assigned to tenants, and you want to, as I mentioned, to provide network services on top of that. So we also build the technology, and it's actually part of the product, where you can have a virtual machine or a number of virtual machines running on servers, and these virtual machines provide the entire array of the whole spectrum of network services. You can do it very efficiently in one VM, provide all these network services without having to copy packets between these services. And so there is a firewall, layer 3 to layer 4 firewall, NAT, load balancer, IPsec VPN, router. So all of that, we call it VNS, which for virtual network services. So here in this example, you could have these tenant networks and that are strictly, let's say, on the InfiniBand Fabrics, so they have no uplink. And then you could have a network that is connected to the external Ethernet, a virtual network with an uplink. And you could provide firewalling, load balancing, routing between these different virtual networks, between the network facing the external world, let's say the internet, and the tenant virtual networks. So what's the hardware that goes with this? This hardware is part of a portfolio that Oracle recently announced. So there is a host channel adapter, a EDR, 100 gigabits per second host channel adapter that includes the functionality that I mentioned, that for the offloads and for the security, the firewall, the anti-spoofing capabilities that I mentioned. The gateway is a device that is integrated in these two systems. You see the one in the middle, which is a leaf switch that has an Ethernet gateway with 2 40 gigabit ports on it and 8 10 gigabit ports. Those 10 gigabit are SFP+. So you can basically connect those to Ethernet networks and provide the gateway. It has a low latency hardware-based gateway, and you can connect to different isolated Ethernet networks, like I said, with all 4K VLANs on each one of them, and then assign virtual networks to those ports and basically provide connectivity to the Ethernet, the InfiniBand servers to those Ethernet networks. And then there is a bigger system. So the middle one, the leaf, is a 1U system, and then there is a bigger one, the 2U system, with, which is a modular system with 12 slots, where you can have Ethernet gateways. There's a quad 40 gig Ethernet, which can also be split. Each 40 gig can be split into 4 10 gigs, so you can have 16 10 gig coming out of that. And also it has a module that's a quad 10G base T. So it has very rich connectivity into Ethernet. You can have multiple of these modules in the system. And also the network services module, which is a module with 2 Z&D processors on it, where you can run those network services that I mentioned, load balancer, firewall, router, and so on. You can either run as a virtual machine on the server, or you can run on this blade, on this module. There are other modules there where you can connect to the software-defined networking for fiber channel and other things there, but I'm focusing here on the Ethernet side. Okay, so that's the hardware, and then you need a way to manage the whole thing, because that's really what you can have the underlying support, but then if it's not easily managed, it's not really that usable. So this also, you need a fabric manager, which in this case, what we're doing here is provide a GUI-based fabric manager, which can also be used with REST API, so connected to other orchestration systems, can be connected to OpenStack. We actually connected it to OpenStack. And this provides you the ability to define these virtual networks and then use them. You can assign them to servers, assign them to virtual machines, and create basically templates of I/O profiles of servers and virtual machines, where you could say, this is the kind of connectivity that I want for particular servers or VMs, and then you can apply that template to many servers at once or many VMs. So you can have these different kinds of connectivity profiles and apply them to servers. You can even pre-provision that, so the servers or the VMs may not even be there yet, but when they come up, they will get the I/O that was configured. So this is a very powerful system with performance monitoring and so on. So basically, really get the management and the monitoring of the software-defined networking. Okay. So basically, you have all the building blocks of SDN. So basically, you need the virtual networks, and then you want to have the services that go with the virtual networks. On the server side, you need the ability to tie it into applications or into virtual machines. So virtualization of all these adapters, the NIC, the HCA, the fiber channel HBA, I mentioned we do that as well. So basically provide virtual I/O to the servers. And then on the fabric side, on the gateway side, you need to be able to connect dynamically to multiple physically isolated LANs and SANs. So when you have all this coupled with the management, the fabric manager, then you truly get that flexible connectivity. So I mentioned that we wanted to provide multi-tenancy for cloud-type environments with this technology. So basically, I mean, in here, what you see is that you have this combination of isolated tenant networks, And then you have network security services that are protecting the tenant domain. So I mentioned you can do the network services, the firewall, VPNs, so you can isolate from a data plane perspective the traffic that goes to these tenants. And then from a management perspective or administrative domain perspective, the tenants are limited in what they can manage. So they cannot manage somebody else's overlay networks, let's say, so, or their gateway resources. So there is an ability in the management system to carve out the resources into domains for different tenants, and then they can only manage what is allocated to them without being able to touch other resources in the fabric. And then you also have a cloud admin that has the ability to touch many things, maybe everything. So there's roles and domains in this system to provide this security and isolation. Okay, I mentioned OpenStack support, so I'll just say a few words about that. So we wanted to support environments that use OpenStack. So we developed, for this SDN solution, we developed a mechanism driver for Neutron, the networking part of OpenStack, which enables this technology. You see PVI plugin. PVI is just what we call virtual networks. It stands for Private Virtual Interconnect. And so essentially, what you can do is when you create a tenant network in OpenStack, it is possible for us to create a virtual network on InfiniBand for that tenant as a tenant network. And that happens with this mechanism driver that we have in the Neutron component of OpenStack, the networking component of OpenStack, which talks to our Fabric Manager through a REST API and creates the relevant virtual networks. Also, when a virtual machine for a tenant is instantiated on a compute node, automatically the system will create the appropriate virtual NICs on the compute node, connect them to the virtual switch. So basically provide all the plumbing automatically for the tenant virtual machines on the compute nodes. Can also be used for storage connectivity on the block storage component of OpenStack Cinder, where the iSCSI target can be using one of these virtual NICs on a virtual network to provide iSCSI for an initiator that's on the compute node that also uses a virtual NIC. So we have that as part of this solution as well. Okay, so I promised to say how we used it in a product in an engineered system. So we have something called Private Cloud Appliance, which has been on the market for a couple of years now, and it's currently using the existing technology from the Seago, where basically, those two black boxes that are actually now silver color. But that appliance is based on this software-defined networking technology. The entire networking and connectivity of this appliance is based on this technology. So this has a number of servers, 25 servers in the space rack. You can have expansion racks with 30 servers, and they are connected over InfiniBand. There are a couple of management nodes, and a storage server. There's EFS storage, and basically the connectivity to the external world of this appliance is through gateways, InfiniBand to Ethernet gateways, connecting to Ethernet networks, as well as gateways connecting to fiber channel. And the appliance has virtual networks for the different applications, the different tenants that can be hosted on this appliance, using this SDN solution that I mentioned for the tenant networks or the application networks for the server-to-server communication, as well as the server-to-external network communication. So this is an appliance where we use this technology in practice. All right, that's what I had. Any questions?
Interesting thought on the DN over IB, but can you articulate what will the value prop of this architecture versus standard class Ethernet fabric in terms of security or latency or scalability?
Right. So clearly, there are the advantages that you get from InfiniBand in the sense of the cost performance of the technology itself, as well as if you're looking at trying to build an Ethernet-based solution compared to this, in the comparison, in addition to the cost, you can see also the cabling reduction. We architected this in a way where you can have a very dense solution. We use between the leaves and the spines 12x cables, so you basically can have cable reduction in the leaf to spine between the leaf and spine layer. So there are those aspects, but in addition to that, you have all the value that you get from InfiniBand. So you basically the application, and as you well know, Oracle has many applications that make use of the underlying InfiniBand fabric. So here you get the convergence of everything coexisting. So you have the ability to do the inter-process communication, high-performance communication over InfiniBand, and also get your Ethernet connectivity with the software-defined networking. So you don't have to choose one or the other. It's all combined on the same fabric. And so you get the value of both InfiniBand and SDN in one fabric.
So you're saying it will be cheaper than the class Ethernet fabric?
For a comparable level of performance, yes.
Wow, okay.
Any other questions? No. All right.